Okay, let's start now. Fundamental method of multiplication is our name. Actually, most of the time multiplication is applicable, but actual is the fundamental principles of counting. Okay, so what is exactly permutation, what is combinations, that is complete all about the 1 month lectures of this permutations and combinations. A very big chapter, a very important chapter of JEE. If you could count a top 5 to 10 chapters of JEE, permutations should be there only. In the top 5 chapters, many questions on the permutations you will find with the PYQs, patterns in permutations and combinations. And actually it is a logic oriented chapter. If your logic is okay, good, then it will be more fruitful for you. So starting from today, we are ending up with the October end on the permutation combinations only. So see how important chapter is. It's not like a simple and straightforward as linear inequalities or sets. Okay. Now see, everyone knows that what is you are observing in a picture. What is you are observing in a picture? No observations. Road. Oh my God. What a observation. Can't even telling like that, man. I am observing man too. Mens, there are many mens on the road also. And Acha, don't say that you are observing trees. Okay, so see, if you read it clearly, RTO ensures all the car plates numbers have unique identity. Yes or no? There are many cars, many car plates numbers generated, and you will never find one number matching with another number. Like how the God is created every human being differently. Same like that only. So it's not like that. Permutation is doing the job of God. It's not at all. So we are talking about numbers or digits or the letters. If we talk about the letters, numbers, digits, there is maybe a unique pattern. Like state is represented by first two letters. Then in which region you are living, that will be another three letters. That can be done. Pattern will be same. But there is a no unique identity will be given to the any of the number car plates. So how this is possible? This is a big question, that how many things can be generated from the given numerals is the important thing, and which can be calculated based on the permutations. Clear? Okay, so this is what I am observing in the picture. Now, so like KA 19, P 84, 88, this is the number. So that is a belonging, one given as an ID, but this is about the reflections. Now think on possible combinations. Now here no permutation is there. Here it is a combinations, because what is the difference between permutation combination, that we are going to see in depth in the next lecture. But I'm just asking you, I have a 3 shirt and 2 pants. Okay, and I just give a question to you, that make a possible dressing up from this two. Okay, what you will do? Don't say that I'll only wear the pants from this combination. I'll only wear the shirt. You have to select one shirt as well as one pant. So how many ways are there to select? Yes, very good. So there is an selection of 3 shirts. Yes, there is a selection of 3 shirts and 2 pants. And is very important. There is no alternative to this and. So that's why it is multiplied. Clear? So it is 3 to the 6 possible combinations are possible with this dressing. Clear? So here comes the first principle, that is the first technique of counting. So we are all learning the techniques of counting in this chapter. And if you're going to want to do the something extra in maths, extra in mathematical way, like after some days, if you feel like everything is bore, JEE is also bore, I want to do career in maths. If you are feeling like that, then combinatorics. Combinatorics is the one of the branch of mathematics which increases the permutations combinations knowledge. It is a worldwide use concept, and there you will learn the programming and algorithms of the combinations and permutations. Clear? Okay, so this is a very important unit. Like how trigonometry is one part of mathematics, same way permutation and combination counting techniques is one part of the mathematics. Okay, so we are starting with the basic. Don't worry, I'm not going to tell you the everything that is out of your coverage now. We just will study that things only. But now what we need to recall, what counting techniques you know, up to 10th or 11th half curriculum. Ma'am, I know how to add, how to subtract, how to multiply, how to divide. These are the counting techniques, no? Okay. I am also knowing that only up to 11th. No? Now I am knowing everything, but up to 11th, we know this much only. Adding, subtracting, multiplying, and division. Yes or no? So we need to know about the counting techniques, grouping, statistics. These are also counting techniques. Yes or no? Statistics, grouping, branching. If I take the count of your class, how I'll count? Either with the name one by one, or I have 3 boys, 2 girls. Means that is a grouping technique. Yes or no? So same way, there are many counting techniques. Okay, so sets, under sets, there is a Venn diagram is important. Intersection and union is important as always. Complement is important. Next, multiplication and factorization. Factorization is a two important thing. If I tell you to factorize 512, how you will factorize? Tell me the factors of 512. So 2 raised to 9 will be the answer. Clear? So likewise, we need to factor it in terms of prime numbers. Clear? Okay. It may be the combination of 2, 3, 5, 7. It may be the combination of 11, 13, 29. Clear? So we need to factorize in terms of prime numbers. So I have shown the calculations of very simple figure, that is 512. Even it is even, so we can able to make a factorization. This is a one kind of factorization, and another kind of factorization that you know in terms of identity, but most of the time we don't have the XY consent till now. And multinomial theorems only we have this content. Okay. So what is the overall review of this chapter? First understand. First thing is the, we can say, fundamental counting principle, FCP. Okay. Second session is all about the permutations of the distinct object. Okay. Third thing, permutations of the similar objects. Okay. Fourth thing, permutations in the circular way. Fifth is the combinations. Sixth is the properties of combinations. And seventh is the miscellaneous questions of the permutations. Eighth is the miscellaneous questions of the combinations. Clear? So this is all about the permutations and combinations. Today onwards, don't take this like ma'am is telling everything about permutation daily. 1 month this chapter is going on. Okay, so this is a very big chapter actually from JEE point of view. Now in my daily routine session, you will just listen this word permutation, permutation, permutation. It will be a similar word in every session, but you have to bear me for that. Now, fundamental counting principles, sum rule and product rule. Factorial notation, properties of factorial notation. If you found exponent of prime p in n factorial is an important thing. And I, don't tell me in ulta I. Most of the time, if students don't know the notation factorial, they are reading it as n ulta I. So you can read for time being n ulta I, but it's n factorial. Okay. Now, let's start. Fundamental counting principle of sum rule and product rule. If you know a very simple concept of sets and or, from out of your class, we have 1, 2, 3, 4. 4 girls and 3 boys. And our class currently we have 4 girls. Out of your class, I just want to select the monitor. How it is, I'm giving the two cases. First case is, 1 minute. Minute only. Okay. So, out of your class, I just want to select one girl and one boy. Now I'm just giving two situations, two scenarios over here. I want to select one girl and one boy as monitor. This is my case 1. And my case 2 is I want to select either one girl or one boy monitor. Got it? This is a simple concept of sets also. When we have and case or both case or any other case where and is substitutive, that is a different case and or is a different case. Okay. Now what will be the answer? Think on this. Currently what I have, 3 boys and 4 girls. What will be the answer of case 1? What will be the answer of case 1? Okay, how many chances of selection of girl over there? Obviously, girl will be selected from girl only. So we have only 4 chances. Okay, what are the chances of selecting boy? 3 chances are there. And if it is and, I want one girl as well as one boy, so it is multiplication. So 4 threes are, there are 12 possibilities or 12 ways of selection. Clear? In the opposite case, I have one girl, 4 is okay, or one boy. That means 3. So total ways of this doing this task is 7. Clear? This is the difference, and these are only your fundamental counting principles, which are sum rule and product rule. Clear? Clear? For the performing first task, I have m ways, and for performing second task, I have n ways. If I want to do that both operations together with the connective and, then it is a multiplication. If I want to do the both the operations either or case, or is the connective, then this will be a sum rule. Clear? Both the principles are clear. Very easy, no? Very easy. Okay. Now, my question, as I always love to ask question after explaining the content. This is fine. I have these two cases, fundamental counting principle of sum rule and product rule. Now I want to connect this with the chapter sets, because JEE is like DNA pattern only. It will be always a hybrid variety. So if I want to connect this chapter with the sets, which one is the intersection and which one is the union? Which rule is representing union? Which rule is representing intersection? Multiplication is union. Okay. Is there any other opinion? Everyone write your opinion. If it is repeated, then also fine. Everyone's reply there must be there in the chat box. There is no bound for thinking. You have to answer regularly. Correct, wrong is the next concern. Case 1 union, case 2 intersection. Okay. Any other? Anil Dev done, Karishka done. Mukeshwaran, Achaya, Bhuvna, Netra, don't say like ma'am, we are with you. I'm not, till now I have not given the answer. I just want answer from you. And intersection, case 1 union and intersection. What and intersection? And means intersection. So I must appreciate Ashrita for her answer. The case is reversible. Always we are very habitual that a bigger answer is union is producing a bigger answer. Yes, no, union is a bigger set. This set plus this set is union, right? No? So where the bigger answer is produced? In the multiplication, clear? But in the set notation, it is completely reverse situation. How it is? Now I am going to explain with the help of set. Just see. This is my rectangle of complete set universal set U. Then under that I am representing two circles. A set of girls, B set of boys. So I'm just keeping girls set bigger one. We have girls count greater and 3 boys. Okay, clear? Now I just want to select a girl and a boy. Which is a region of and? This is a region of and. Getting clear? Here we have the data of girl and boy. Clear? So whenever we are getting girl and boy data, that means it is nothing but a intersection part. Clear? So first operator is intersection. And the second operator is the union. Now clear? Now clear? And what is the union? Union is nothing but this part. This complete part is union. Clear? Either girl or boy. So it is representing a girl or boy. Clear now? Okay, so this is about the fundamental counting principle. So we'll have a look out over the fundamental counting principle. See if a first task can be performed in M ways, while second task can be performed in N ways. This is the official definition I am explaining. It is in your textbook. That's why I'm keeping. Okay, otherwise no need. Now, the task cannot be performed simultaneously. This is an important thing. Then performing either one of these tasks will be accomplished by either or. There is a situation either or. Okay. So this is an or case. That's why operation is M plus N. Okay. It is represented in a set with which operator? Union. Got it? Clear? Next. If a task is performed in M ways, second task is performed in N ways, that is fine. Then the both is another word or and is the connective. Clear? Both is also fine with and. Okay. So it is M into N ways. That means it is a intersection. Clear? Yes or no? So simple question for everyone. Try to solve this one. This is the JEE Mains question. I don't know year. I guess 2019 or 16. Before AIEEE was there. Now JEE is just a one level extra for maths. We can't expect such simple questions in under maths. If it's your good luck, then also not only. Quickly, I want answer. There is no any other rocket science in this question. It is a straightforward question. Yes, and don't answer me in a now intersection pattern. If it is connective with the sets, then and then only. What will be the fundamental counting principle then? 12 gates in a hall has 12 gates. How many ways can hall we can enter through the one gate, come out of through the different gates? Now see, I'm drawing one hall. This is my hall. Just imagine. I have 12 gates over here in an entry point. Okay. Now, in how many ways can a man enter the hall through one gate and come out through the different gates? Now, what will be the answer? Just imagine, then and then only your answer will be. Now see, okay, I know you are going to confuse in this. For example, I am using this gate. Obviously, if these are the entering gate for me, then automatically remaining gates are exiting gate for me. Yes, now you got the concept. If this is an entering gate for me, first one is my entering gate for me, so remaining 11 will be exiting gate for me. Yes or no? So I can come in the one way, obviously, but there are 12 options for the first task. Clear? Okay. So how many options to enter? 12. Okay. And how many options to exit? 11. And both tasks can be performed. Yes or no? This is and communication because I am entering also and exiting also. So we have 12 into 11 will be the answer. Clear? Got it? Yes or no? Netra, Ashwin, Bhuvna, Ashrita, Achaya, Mokeshwaran, Kanishka, Anil Dev. This is a chapter where you'll again and again think that why I didn't thought this. This is a very logical chapter. Here logical powers works. Achaya, thank you for your answer. I appreciate this answer. Now, next one. This much is space for this question. No need. Okay, how many numbers between 10 to 10,000 can be formed by using the digits 1, 2, 3, 4, 5? If the no digit is repeated in any number, digits can be repeated. Let's consider the digits case first. First, we'll consider second case. Making an number. Okay. So how many numbers in between these two numbers? Either it will be a 2-digit, right? Or it will be a 3 digits. Clear? These are the only 3 cases. Acceptable. Why I'm not putting a 5-digit one? Because we want a less than 10,000 and one is already fixed. If I plus 2, it will be 20,000. That will be greater. If I plus 3, that will be 30,000. That will be greater. If I plus 4, that will be 40,000. That is again greater. If there is a 0 is given, then the cases may be different. Clear? Okay, but now whatever the numbers are given that are already greater than 1, that's why we don't have option like that. Yes or no? So we need to create case 1 of 2-digit number, case 2 of 3-digit number, case 3 of 4-digit number. Got it? Clear? Now if repetition is allowed, I'm guessing. Now see. Okay. I'm keeping the second case as the first. Repeated, allowed. Okay. How many ways 2 digits number can be created? If I place any number can be acceptable over there and any number can be acceptable over here. Yes or no? Any digit is acceptable. 1 2 1 3 1 4 1 5 2 1 2 3 2 4 2 5 3 1 3 2 3 3 3. So I have the 2 digit number creation. So this is my case 1. I'm just naming cases. These are my cases. Now with the first case 5 into 5 2 digits number, right? Then for third case 5 into 5 into 5. Okay. Then third also 5 into 5 into 5 into 5. There are 5 chances to this. Okay. Got it? Clear? Now either case 1 will arise or case 2 will arise or case 3. Either we can create a 2 digit number or 3 digit number or 4 digit number. Got it? Clear? Okay. So this one is filled with the connective R. So total answer will be 25 plus 125 plus, right now, clear? So it will be 25 plus 125 plus 625. So total answer you can better answer. Got it or not? First means second case is clear. If the digits are repeated, we are able to put any digit over any place. So 2 digits can be formed with the 5 into 5 chances. 3 digit can be formed with the 5 into 5 into 5 chances. And 4 digit can be formed in the 5 into 5 into 5 into 5 chances. So what is total? 75. Are you sure? Okay. Now knowledge given to you for repeated one. Can you please try it for the non-repeated one? Just try your answer and give your answer. I want 200. Okay. So everyone put your answer for the first one. Very good. 200 is the correct answer. So everyone is thinking. So case 1. See the case 1. 2 digit creation is case 1. If I have the 5 chances to fill the place of. We'll start with the unit place. Okay. When we are creating a number, we are starting with unit place. Okay, fine. I have a 5 chances to create a unit place. Then what will be, if I put anyone over there, the chances are 4. In case 2, what are the chances? 5 into 4 into 3 chances only. And in case 3, what are the chances? 5 into 4 into 3 into 2. So 5 4s are 20, 60, 120. So we have the total number of digit creation. Either case 1 will occur or case 2 will occur or case 3 will occur. So total number of chances is 20 plus 60 plus 120. So total is 200. Got it? Cleared? A big smile on your face, please. I think I am teaching you correctly and you are getting everything whatever teach to you. Cleared? Okay. Some students don't know how to smile. Come offline sometime. If I could take your 1 hour session offline, will be very inspired with the maths. Then you will only are going to attend the math session only. Okay. So next, factorial notations. Now this is a very big thing to multiply and divide and add. So obviously scientists have some tasks to do, no, every time. Scientists have to do their work, no. So they are doing their work. So there is an creation of factorial. So what is a factorial? If there is a case, the multiplication of consecutive numbers is required. So they have named it as in one term. Mathematically, algorithms for computers, it is a term factorial. Clear? Okay. So if you could put symbol in Excel also factorials, it will getting multiplied. If I put 12 and factorial as in program, then automatically the answer will be generated 1 to 12 multiplication. Clear? So now what is mathematically? Let's understand the definition. The product of first and natural numbers. This is a very important. If the numbers are not natural numbers, whole numbers. If I could multiply 0, everything will get 0, no? Yes or no? So it is the first and natural numbers is denoted by n factorial and read it as factorial n. Okay. Now, what is 1 factorial? 1 into 1. So 1 is 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and so on. Now, this many times students ask, what is 0 factorial, ma'am, then? Or scientists have to produce a result for 0 factorial. Yes, no. So it is 1. Clear? 0 factorial is that exceptional case. You have to always remember that 0 factorial is equal with the 1. Now, everything is done. You have to know how you are knowing the tables for the 5th or 6th standard. I don't know exactly in which standard you have remaining tables. 2 ones are 2, 2 twos are 4. Yes, no. So there are many tables in the permutations. We have one more table of de-arrangements. But now we have arrangements, that is factorials. Okay. So you must know the basic 10 factorial values. So in the next lecture your task will be, you have to come with the values. 1 factorial is equal to 2 factorial. I'll give the chance to anyone randomly. Just express all the factorials. So 1 factorial, 2 factorial is equal to, 3 factorial is equal to, and what is the case? Up to 4 factorial, we can do the multiplication in mind also. But after 5 factorial, your mind is like, I don't know how to multiply. So you have to remember the factorials. Clear? Okay. 1 to 10. And then above 10, we can easily get it with the use of this 10. Okay. Now, so this is about the chart. So what is your homework? Remember up to 10 factorial. A very, 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 very important thing. Clear? This is a very important thing. Okay. Now, so many times students gets confused in the cancellation of factorial. So that's why this is a pretty important formula, that we must resolve the numbers in the reverse order instead of proper order, because if sometimes we don't know the value of n, then reverse also is going to give the same answer. No, 3 factorial is 3, 2, 1. So reverse order, kindly remember it always in the reverse manner. So reverse order is extremely important, and that will help you to generate a correct calculation. Clear? Okay. And don't miss any order. Sometimes this happens when we are doing 11 factorial. We're taking 11, 10, 9, sometimes miss 8. Then your answer will be collapsing. Clear? So n factorial is n into n minus 1 into n minus 2. Now, the next one is, before to calculate, I'll just want to suggest, there isn't some operations regarding the factorials that was not included in the PPT. I just want to explain it as a random board. Okay. So see. Operations of full tie. Okay. Now what is the first operation? Addition. Next operation is subtraction. Third operation is multiplication. Fourth operator is division. Fifth operator is scalar multiplication. Now pay attention. I'm just taking a small examples. If I want to perform the calculations of 6 factorial plus 4 factorial, what I will do? Or what you will do? Now I'm taking about 6 and 4. But what if it is 101 factorial and 102 factorial? So you have to take a smallest factorial. Clear? Which one is the smallest out of 2? 4 factorial. So resolve biggest one up to smallest one. So 6 into 5 into 4x factorial. 6 can be reversed. So this is an important thing to remember. Student may forget this one. We can convert a largest to smallest factorial. Clear? A largest factorial can be convertible to the smallest factorial. How it is? We'll show with the simple example. I want to resolve 10 factorial up to 6 factorial. What you will do? 10 into 9 into 8 into, first I'll resolve up to 7 factorial. It will be 7. If I want to resolve up to 6 factorial, 7 into 6 factorial. Clear? So any n factorial can be resolved in the n minus way factorials. Okay? Clear? So whatever is your comfortable thing for that particular question, you have to do that. Okay? Now, for this particular question, I need up to 4 factorial. So I can resolve it up to 4 factorial and then that take 4 factorial common and add remaining things. 6 5s are 35 plus 1, that is 36. Sorry, 31. Right? Yes or no? So this one will be the answer. And then you can do the multiplication 4 into 3 into 2. So in the subtraction also you have to do the same thing. You have to take something common, means smallest factorials common. Okay. Then in multiplication, obviously you need to multiply only. 4 factorial into 2 factorial. There is no alternative. You have to multiply all digits. Clear? No alternative for multiplication. Multiplication is not many times asked. So if it is 4 factorial into 2 factorial, do as it is how you can do. Okay. Now division is important case. If I have 5 factorial upon, first case I will take it 6 factorial and then 6 factorial upon 5 factorial. What you will do? Yes, very good. In the numerator, second case it's easy because we have a smallest value over denominator. So it is cancelled. 6 into 5 factorial completely cancelled, directly answer will be 6. But in this case, you need to do it as 1 by 6. This will be a fractional answer. Clear? Clear? How you are doing division? And the division, biggest factorial can be resolved up to the lowest factorial and cancelled. Okay? And scalar multiplication, if I want to do 2 into 10 factorial, if it is required for answer, then only do it. Okay, this is the operation. If it is required for answer, then and then only do it. If it is found in options only, like 2 into 10 factorial is there in your options, then do that only. Clear? Don't waste your time. 10 factorial calculations is not easy. Okay, because it's a multiplication, it's not addition. Clear? Now we are okay. So find n if n plus 6. You'll do this, everybody. Now first tell me which one is bigger and which one is smaller. If you could able to judge that, that is thing only possible over here. I'll take a case 2 over here also. Just 10 substituent questions. If it is like n minus 6 factorial, such question will be not given to you at all. But n plus 6, yes, here n plus 6 is a big value and n plus 4 is a small value, and we can convert big to small. Okay, here n minus 6 is a small value and n minus 4 is a big value. Clear? But such questions are invalid because n will be not a perfect integer then. This point is invalid. The question is invalid. But how this is invalid, that is understanding important. Clear? N minus 6 is small value and n minus 4 is a big value. Do it. Very easy question. Do it. You can do it by yourself also. N plus 6. Then next term is n plus 5. Just do minus 1 each time. Clear? So what will be the answer? There must be a two consecutive. What is a consecutive means with? Because it required in the next chapter also. We required two numbers which are coming one after another. That is a consecutive. Clear? So what is the two numbers which are producing product as a consecutive term? 8 into 7. Don't write 7 into 8 because we have first one largest, another one smallest. If I compare any number, n plus 6 is equal to 8. Therefore, n is equal to. Got it or not? Or you can compare another also. Answer will be by the way same. Clear? Clear? Is there any doubt? Okay, should I take next one? We have properties everywhere. In the JEE, properties are very important. You will never find these properties in state board pattern, but patterns in the JEE always you have properties of modulus, properties of complex number, properties of conjugates, whatever it is, properties. JEE is all about learning and understanding the properties. Now, n is resolved as n into n minus 1, that we know. If n is greater than 1 positive, then we can write down up to the n into n minus 1 into n minus 2 pattern. So this is like we can do as per the question. M plus n factorial is always divisible by m factorial as well as n factorial. Example, 3 plus 4 factorial is divisible by 3 factorial and 4 factorial, but it is never following the commutative law. Clear? This is an important, like how we are doing in addition, it is not following in a factorial pattern. M greater than n, then m minus n factorial is not equal. This is also important. Okay, so it is basically not following the commutativeness. Clear? In the plain addition operation, what we have, 2 plus 3 is equal to 3 plus 2. Okay, but here in the factorials, it is not following that. That is the only concern. Next is find n. Do this one. Try this example. It's a ratio. Okay, so if it is basically a ratio, we need to write it in this way. N factorial upon 3 factorial into n minus 3 factorial upon n factorial upon 5 factorial into n minus 5 factorial, which is equal with 5 by 3. Okay, n is equal to 7 is the correct answer. Now just pay attention. What is exactly the needful thing in this pattern? First thing, student many times get confused that what to be cancelled and what to be resolved. Okay, which one is big factorial, which one is small factorial. And already we are producing the result for sorting the things. Yes or no for sorting the n values. Don't multiply any bracket. If you could multiply n minus 4 into n minus 3 to form the identity n square minus 7n plus 4 3s are 12, then tata bye bye. Then go and sleep and don't solve that question. It will be not reduced to the factors. Okay, so don't multiply brackets here, not needed. We are sorting the n values, so whatever factorization possible, just do that only. Okay, now see the first factorials, and as your JEE students you must have to do it in a very lesser steps. Don't do like that. A plus B plus C plus D is equal to 21. Then A plus B plus C is equal to 21 minus D. This is not the case of JEE. You have to solve any question for the JEE in the less number of steps. Okay. Now I am just showing this calculation. See, if you could ask me this question to solve, it will require hardest 2 steps to solve for me. And you have to attain that same speed or same style. Okay, but now I'm solving to make you understand, and if you could anyone check this recording later on, they must clear with the calculations. Okay, so that's why I'm taking these numbers of steps, otherwise it is not needed. Now n factorial upon 3 factorial into n minus 3 factorial upon n factorial upon 5 factorial into n minus 5 factorial. N is bigger, n minus, if we consider only for numerator, n is big obviously, and n is n minus 3 is small. Same about numerator, it is big, it is small. What you will do, resolve bigger one up to smaller one. So this is n minus 3, n minus 3 gets cancelled. Here n minus 5, n minus 5 get cancelled, right? Now there is one more property. We have the ratio of a by b upon c by d. There is a property that numerator gets cancelled with numerator. This a get cancelled with c. Yes or no? Because after reverse multiplication, by the way, that will be equivalent with a by b is equal to d by c. Clear? Okay. So how I am cancelling n with n minus 1 with n minus 1. See, if it is in denominator, there is not ability to cancel. That is mathematically wrong. N minus 2 cancelled. So what are remaining things? Here 1 by 3 factorial, here n minus 3 by n minus 4 upon 5 factorial, that I have not written. Directly this one will be the identity. Clear? Now here also we can cancel 5 up to 4, 3. So 5 into 4 into 3 factorial. Then we can cancel this 5 with this 5. Numerator on both end gets cancelled. So this is how you can reduce your calculation. I got n minus 3 as a bigger number and n minus 4. So this multiplication will be written in that manner only. If n minus 3 is big, on this end also bigger number will return first. If you could write it reverse also, many times happen, no? Now it is 4 and 3, you are able to do this technically, but if it is 51 52, you will get confused. So obviously bigger number must be written first to compare. Okay, so n minus 3 is compared with 4 only, that's why answer is 7. If you could compare it with 3, your answer will be wrong. Clear? And JEE is so smart to place all the consecutive options. Okay, now this is the calculations. Now remaining things are related with the calculations only. N minus 3 is compared with 4. That's why n is equal with 7. Understood? Clear? Now we have a one more new concept of the JEE, that is exponent of p in n factorial. That is a completely concept introduced for JEE, but we'll have that content afterwards. You want a break? What? Everyone is smiling for break or not want to break? Or I am asking, that's why you are smiling. Okay, take a 10 minutes break, then we'll meet for the exponent. Okay. Hello everyone. Am I audible? Let's get back to the session. Hello, Bhuvna, Netra, Ashwin, Mukeshwaran, Achaya. Am I audible? Okay, let's start. Ashwin, Netra. What happened? It's more than 10 minutes. Already 13 minutes you are taking break. Okay, let's start. See now. Exponent of a prime p in a n factorial means what? How much power prime p can take in that factorials? Means what? If I give the answer for 2 factorial, is there any power for 3 in the 2 factorial? No, because 2 factorial is already 1 into 2, right? No. But if we can take the factorial of 10 factorial. 10, just forget about 10. We'll first start with the 5 factorial. 1 into 2 into 3 into 4 into 5. What is the answer of 5 factorial? What is the answer of 5 factorial? 5 4 is 20, 3 to the 6, 20 into 6, 120. Clear? Now, if I could ask you what is the power of 2 in 5 factorial, what you will answer? 1. Yes, no? What is the power of 3 in 5 factorial, what you will answer? 1, because we are finding this powers 1. What is the power of 5 in 5 factorial? 1. Clear? Up to this is clear. What is this exactly pattern? Pattern is cleared. Okay. Now, this is about the first thing. Next is, if I could ask the same question, what is the power of 2 in 10 factorial? Is it that much feasible? If I could ask this same question, what is the power of 3? How you will answer? 100 factorial. Is it that much feasible? No. Okay. So we have to do this in a formula. So we have to resolve this formula as e to the power p means e3 of 10 factorial will be equals with n upon p means 100 upon 3, 100 upon 3 square, 100 upon 3 cube, 100 of 3 4. Clear? So now students will ask, ma'am, how much power we have to do this? Yes or no? That is the main thing, no? So how you will do this one? Now, first you need to understand this close bracket. What does this means? Greatest integer function. What is the answer of this? Greatest positive integer function. We are taking the covered lowest integer. Yes or no? If I am getting the greatest integer of 33.2, what will be the answer? 33. If I take the greatest integer of 31.4, what will be the answer? 31. Clear? So this is an greatest integer function. Clear? Remembered, we have already seen this one in the functions. Now we have to do this one unless and until we are not getting any power p to the power a must be less than n. For that value only we have to take. Clear? Okay. P to the power a must be less than 1. Clear? Okay. If we are getting any of the answer in the pattern, like simply just remember that numerator is less than, if we see numerator must be always greater than denominator. This is up to that value you have to go. Clear? Okay. If there is a case arises that numerator is less than denominator, then what will be the answer? Answer will be in a point. Yes or no? Clear? So that is not an acceptable case. So you have to remember like minute. Must be continued this procedure unless numerator must be greater than denominator, and then stop. Clear? Okay, then stop. Like I'm just searching, we'll take a some simple figures first. 3 in 100 factorial. How you will resolve? How you will resolve this one? 100 upon 3 plus 100 upon 3 square is 9, right? What is 3 raised to power 4? What is 3 raised to power 4? 81. $243. Now we have to stop. This is not acceptable. Clear? Okay. Now just do this one. What is 100 by 3? Greatest integer only. You have to take the initial value only. 100 by 3 is coming 33.33. So we get a perfect answer 33. Clear? Plus 100 by 9 is coming 11.11. So it is 11. Clear? Plus 100 by 27. What will be the answer of 100 by 27? It will be 3.7. So 3. Okay. 100 by 81. What will be the answer? 1 point something. And this is a 0. Hence onward it is a 0 only. Clear? Okay. So what is the answer? 33 plus 11 plus 3 plus 1. So 48. So what will be the answer? This one is the 48. Clear? So the power of 3 in 100 factorial is maximum up to 3 raised to power 48. Getting clear? What is the power of exponent in 100 factorial? 48. Clear? This is the formula and how to apply it. Clear? Okay. Now let's proceed with the JEE questions. So stop. This is a note down thing, that stop where n is less than p raised to power alpha. Clear? Stop where n is less than p raised to power alpha. Now see the question. A boy can escape through the window of size at least 4 feet. Okay, that must be 4 or above. At least 4 means what? Everything in the permutation combination works logical. Okay. So at least 4 means what? 4 and above. Okay. The 28 windows of the house are of the size 2, 3, 4 and 5 feet. And their number are proportional to their sizes. Okay. So sizes 2, 3, 4 and 5 feet. And numbers are proportional to the sizes. The number of window available for the boy to escape. Try to answer. First thing, number of windows must be calculated. Number of windows that are 28, but with that size 2 we have 2k windows. Yes or no? Clear? With the size 2 we have 2k, plus with the size 3 we have 3k, plus with the size 4 we have 4k, plus size 5 we have 5k. Okay, and all is equal with 28. So what is the value of k? Up to this is clear, but k is not a final answer. That is the thing to be understand. Okay, so number of windows of size 2 is, how many windows are there with size 2? How many windows are there with size 2? This is the same. With size 2 is 2k is equal to 4. With the size, next size is 3, 4, 5. No, so 3 is 3k, 4 is 4k, 1 minute, this one is 8. Okay, now which is a principle used over here, addition or multiplication? Just read the question and get the answer. Addition or multiplication? Obviously for escaping or option is working. No, just imagine yourself, you can able to get the out of window 1 and 2 together and is working over there. You have to break your body in 2 parts and then only escape. So either boy will appear for first one or second one. Clear? So or is the acceptable case. So this is then basically the addition principle, right? So it is working with the addition principle. Now tell me answer. Now it is so simple to answer. Tell me option. 18 plus 10, 28. 28? Okay. One more thing is given, no? So one more thing is we have left, like how I am doing. Just don't do that. Don't forget anything to read. See, the number of windows available were 5. But one more thing is at 4 and above is acceptable, no? Acceptable situations only we are missing. 4 and above are the acceptable situations. So what is the acceptable case? Either 8 window or 10 window. These are only acceptable case. So it is 8 plus 10, that is 18 ways to escape. Clear? Okay, so we have which one as an answer? Thanks God 28 is not there in answer. Otherwise I'll do the same thing. Mark the 28 and go ahead. I just read half question only. Okay, now next one. We'll do this one. These questions are very interesting. It is a question of multiplication and division together, and a very easy question. Like I have 5 mangoes, 4 bananas, then how many total fruits I have. Such kinds of questions. Just understanding and reading is very important. See now, a device needs 4 batteries to run. Each battery runs for 2 days. If the total 6 batteries are available, what is the maximum number of days for which the device can run by strategically replacing the batteries till all the batteries are completely drained out of the power. Now, first thing, how many total batteries do we have? How many total batteries do we have? See how simple question is, but you are getting confused. I am damn sure about that. Total batteries are 6. Okay. Running days, how many? 2 each, right? So how many total batteries running days? 12 days. This is in data without any other value. Yes or no? We have 6 batteries. Each battery runs 2 days. That's why the total overall 6 can be run in the 12 days. Now, we required 4 batteries to run the device at a time. Means how much we required 4 batteries to run the device. That is the important thing to understand over here. Now answer. It was to be 12 by 4. So it is 3 days. So if I am utilizing 4 at a time, then it is a division question, like 5th, 6th standard you are done. Clear? In 5th or 6th standard you have done, you must have got across these questions. My God, where we have written the answer? Our answer suddenly got vanished. Oh, here it is. Clear. Okay. So my question for all is 3. Very good. So next further answer is so maximum number of days are 3. Clear? Okay. Next. This you can try. We want to form a 4-digit number. Obviously, if it is a 4-digit number, it will have a unit place, then tens place, then thousand place, sorry, 100 place, and then 1000 place. You will do it? Done? See ya. How many 4-digit numbers there? So see, we'll start with the thousand place. Whenever there is a digit filling problem, normally we are starting with the tens unit place. But now I'll suggest that in the next examples onwards, start with the highest place. Okay. Now how many options are there to fill the thousand place? 1 to 9, right now? So we have total how many ways for the first place? 9 ways. 0 is not counted over there because it will not considered as a proper thousands. Okay. 0 is not acceptable. 0, 1, 4, 1, 2, 3 is actually 3-digit number only. Yes, no? So now, next one. Next place is including. Though I filled over 2 over here. 2 is cancelled now from the digit. But we have 8 plus 0. That means again 0 to, we can say 8 places. Okay. So how many? Any digit is acceptable. So we have total filling ways. That including 0 means all the digits which are left over, that is 8 plus 0 value. Yes, no? 8 plus 0 digit. So total 8 ways are there to fill this one. Now what about this one? So 8 plus 0 digit, that's why we are taking it 9 ways. Now this one is with 8 ways. Obviously 2 digits are lost, and this one will be the 7 ways. Clear? Okay, so unit place can be filled over. Okay. Next one, if we are taking with the principle, fundamental counting principle, this and this and this and is a compulsory case. Clear? So if and is the operator, then we have total answer 9 and 9 and 8 and 7 ways. Clear? We have 4 tasks to be performed at a time. So answer is good. 9, 9, 8, 8, 4, 5, 3, 6. You are sure about your multiplication, no? I am taking as it is. Achha, you are sure about your multiplication? Okay. Don't do it on calculator. NTA is not going to allow you for calculator. Anyone, don't use calculators in mathematics lectures at all. Okay. If I could allow you for the calculations then and then only, because in the NTA exams, no calculators were given. Okay. You need to learn out these steps. Quick calculations, quick addition, quick multiplication. Now, ये तो सबसे easy. You can do it easily, no? Try it. Don't do it in a trial and error way. It is also working over here. If I could place first 50, then 49, then 52, and then 48. Why to not do that? That is also a fine way, no? Place 50 first. Trial and error method. So I'm doing with trial and error. You can do it with the proper method. So let's try with 50. So what will be answer? 52 factorial is equal to 2550 into 50 factorial. So it is 52 into 51 into 50 factorial. I'm doing in this way. Don't do this in this way. So 52 into 51 multiplication. We got this option in a second option only. B option is correct one. Just one by one we need to try the options. If I could try it for the first place to be filled with n is 50, then I am getting wrong answer. If I try with n is 49, then I am getting a correct answer. But go with the stepwise process. Clear? So it may like this question will be asked in an integer type. So you have to solve only. Clear? If the options are not visible to you in the question, then you have to solve only. Can't guess the answer. Can we do n plus 2, n plus 1? Yes, that is only n plus 2, n plus 1. Yes, that is only resolution. Yes, Anil Dev, you are correct. And we are using that method only. I'm going to tell you answer in that way only. So I'm also solving with you to reduce our time. Just take a quick steps. Don't do like you are in a 10th. N plus 2, then n plus 1, then n comes. So obviously it is 2550. I need to resolve 2550 into two consecutive terms multiplication. So see here only you need to stop. Don't go in 2, 3 or all resolutions or factors. We want a two consecutive term multiplication that will be equated with the n plus 2 and n plus 1. Got it? Clear? So I got that n plus 2 is highest number. So we must compare. See, if you want to compare n plus 2, then compare with 51 only. Don't compare reversible. So if I compare highest with higher, comparing, I got it. N plus 2 is equal to 51. So obviously n is equal to 51 minus 2 implies that n is equal to 49. Clear? Yes or no? Big smile on your faces, please. Don't feel exerted. It's interesting, no? Okay. Next is same way n plus 2 factorial is equal to 60, but n minus 1 factorial is over there. Now the big question is arising that ma'am n plus 2 n minus 1 very big distance. We have to do that only. Yes, we have to do that only. Clear? Okay. So with trial and error method, you will find out with trial and error method. Now we'll reverse the case. You find out trial and error method. I'll find it the proper solution. Clear? Okay. Now what you will do, put n value as a option, check. B value as an option, check. Clear? Okay. Do it. I'll do the stepwise process now. Three, 5, 4, 6. Note down the options if you are required. Just message me in a chat box. So n plus 2 is n plus 2, n plus 1, then n minus 1 factorial is equal to 60 into n minus 1 factorial. So with the calculation, I got the answer 7 before you. With the calculations only, oh sorry, 5 minus 2, 3. Gadbad ho gaya. Yes, with the calculations, answer is 3. And with trial and error also, we are so lucky to have the answer in A option only. Just think if it is D, then you will do for A, B, C, and then a D will be the answer. Okay. Next one. plus 2 factorial is equal to 30 into n factorial. Do it. N plus 2 will be resolved as n plus 2, n plus 1, n factorial is equal to 30 into, so simple, only also you can answer. Four is the correct answer. Okay. Now try this one. All are requested to attempt this one. First thing I'll suggest the step to everyone to reduce C. We want a value of X. Yes, no? Okay, I'll make you understand. You have a class assessment also to practice. So see here, just pay attention. If I have an identity of this kind, I need to have the value of X, right? So I'm just multiplying every term with the 7 factorial. This is a quick method, no? 7 factorial upon 6 factorial. It is only X. Got it? So now we will get the answer 7 into 6 plus 5 will get cancelled, 7. So it is equal with X. So X is equal to, if I take 7 common, 7, 6 plus 1, that is 7 into 7. So X is value of X is 49. Clear? So C option is the correct one. Clear or not? Okay. Everybody? Yes. Okay. Now, I'm just giving one more question, then we'll start a class assessment. These are the self-practice question. You can try this question. What is summary of today's session? Fundamental counting principles with the sum rule and product rule. Factorial notation, properties of factorial notation, exponent of p in n factorial. Right? Clear? Now everyone answer this one. Exponent of 2 in 51 factorial. Everybody try this one. You want that formula? You want that formula or it is remembered? 51 upon 2, greatest integer function, plus 51 upon 2 square, greatest integer function. Likewise, how you do? 51, no number of denominator greater than 51. Clear? Okay, do it. Anil, they've got his answer as 47. Okay. Anyone else done with the answer? So from this one is 0. Yes, 47 is correct answer. So exponent of 2 in 51 factorial is 47. Clear? Okay, understood?